In today's video, we'll be going through the process of how to graph polar equations. Well, there are different types of polar curves, those being Limassons, rose curves, as well as circles. Well, now, let's look at the first one, which were Limassons. In Limassons, there are four different types, those being Limasson with an inner loop, a cardioid Limasson, also known as a heart-shaped Limasson, as well as a dimpled Limasson and a convex Limasson. Well, to start off, let's look at the base equation for a Limasson. The base equation for a Limasson is r equals a plus or minus b cosine of theta, or r equals a plus or minus b sine of theta. Also, a is going to be greater than 0, as well as b is going to be greater than 0. Now, you might be asking, what does a and b represent? Well, a plus b equals the entire length of the Limasson, and when looking for the length of your intersection, you have to do b minus a. And a minus b equals the length of the intersection. Let's go ahead and look at a Limasson with an inner loop. A Limasson with an inner loop looks something like this, where you can see that we have a Limasson and then we have a circular inner loop right here. And when you have a Limasson with an inner loop, a over b, the quotient of that is going to be less than 1. That's how you know you have a Limasson. Let's go ahead and do some practice with that. So now let's go ahead and look at the cardioid Limasson. For a cardioid Limasson, you can see it looks like a heart, and for a cardioid Limasson, a over b, the quotient of that equals 1. So it could be the same number. Next, we have a dimpled Limasson, where 1 is less than the quotient of a over b, and that is less than 2. Well, we're going to say that our inner loop goes to 1, and our total Limasson goes to 5. So we need some two numbers which add up to get 5, so plus to get 5, and subtract to get 1. So we know it's r equals cosine because its axis of symmetry is on the x-axis. This means that we have to find two numbers that add up to 5, and when subtracted, they give you your length of the intersection. So two numbers that add up to 5, let's just do 2 plus 3 equals 5, right? And we're going to say a is our 2 and b is our 3. And we said that b minus a equals the length of intersection, and the length of our intersection is 1 because we're starting at the origin. So we need something minus something equals 1, but 3 minus 2 equals 1. So that means our a value is 2 and our b value is 3. So we can do 2 plus 3 cosine of theta. And when you graph this, you should get a Limasson with an inner loop that looks something like that. Now let's go ahead and do a practice problem with our cardioid Limasson. And for a cardioid Limasson, it's going to always start at the origin. Well, the quotient of a and b equals 1. Well, we can see that it's going to be the same number. And we know that if its axis of symmetry is the x-axis, it's going to be a cosine. And we can see that this one has an axis of symmetry of the x-axis. So meaning that this is going to be a cosine Limasson. So we have r equals something plus or minus something cosine of theta. And now we need to find a and b. Well, we know a and b are going to be the same numbers. So let's just say that this is going to be 6. Well, a number subtracted by itself is going to be 0. So it's always going to be starting at the origin. So let's just say two numbers that add up to 6. We can say 3 and 3, meaning that r equals 3 plus 3 cosine of theta. And if you're wondering when it would be minus, well, right now we can see it's facing to the right. If it were to be negative, so it would be r equals 3 minus 3 cosine theta, this graph would be flipped 180 degrees, and it would be facing to the left. But in this scenario, it's facing to the right. That's why we have a positive b value. So let's go ahead and look at the next type of polar curve, that being a rose curve. Well, a rose curve looks something like this. You can see it looks like petals. And there are certain rules you have to follow when dealing with rose curves. Well, first off, the base equation for a rose curve is r equals a cosine n times theta, as well as r equals a sine n times theta. And you might be wondering what the n is. Well, the n is going to represent the number of petals in some way. Here are the rules that I was talking about. The first rule is that when n is an even number, 2 times n equals your number of petals. And the second rule is when n is an odd number, n equals your number of petals. You can think about n equaling half your petals. And in this scenario, a is going to be representing the length of your petal, and n is going to be representing your number of petals, and you must refer to the rules when using the n value. So now let's go ahead and do a practice problem for this type of polar curve. Well, we can see that we have a rose curve right here, and it has a petal length of 4, and we can see that the axis of symmetry is this x-axis. Again, it's going to have the same type of rule, where if its axis of symmetry is the x-axis, it's going to be cosine, and if the axis of symmetry is the y-axis, it's going to be sine. So now what we need to do is right that r, well, the equation's right here, but let's see how we got it. So we know r equals something times cosine something times theta. Well, we remember we said that when n is odd, n equals the number of petals. Well, we have 1, 2, 3 petals. Well, we know n equals 3 now, because we have an odd number of petals, n equals our odd number of petals. So now we need to find the length of each petal. We said the length of each petal is 4, so we have 4 here. We start at the origin, so we have an r value of 4. The equation for this is r equals 4 cosine of 3 theta. Now let's go ahead and do one more practice problem for rose curves. This one you can see that the axis of symmetry is the y-axis, meaning it's going to be a sine graph, so we have r equals something times sine of something times theta. Well, now what we need to do for this type of problem is see how many petals we have. Well, we have 4 petals. 1, 2, 3, 4. And if we refer back to our rules, when n is even, we have 2n equals the number of petals. So if we divide our number of petals by 2, we'll get n. Well, we know n equals 4 over 2. 4 over 2 is obviously just 2, so we know n equals 2 theta. This is our n value. Now we need to find the length of each petal, which is our a value, which goes here. Well, we said that we can see that from our graph, the length of each petal is about 2. This would be -2. And so we have a length of 2. And that is going to be our equation for the second rose curve. Now let's go ahead and do circles, which is the final type of rose curve that we're going to be covering in this video. And the equation for a circle is going to be r equals a cosine of theta and r equals a sine of theta. In the circle type of polar equation, a equals the diameter of the circle. And let's look at this first one. Well, we can see in this first one, we have a diameter of 5. We're going 5 to the right, 5 to the left, and 5 up. So we have a diameter of 5. We said a is our 5, and the basic equation was r equals a sine or cosine of theta. Well, the axis of symmetry is this y-axis, so we're going to say this is a sine value. So we have r equals our diameter, which is 5. R equals 5 sine of theta, and that's our equation. That was really simple. Now let's go ahead and do one more practice problem for circles. This one we can also see that we have a diameter of 5. Well, for this type of circle where it's centered around the origin, the equation is just r equals a again still being your diameter. So now we can see that the diameter is 5, so it's just r equals 5. And remember, this is only when the circle is going to be centered around your origin. Well, I hope this video helped, and if you believe it did, please consider to like and subscribe. I'd greatly appreciate it. We do have an Instagram for future video updates. If you do hit the bell notification icon, you'll be updated on all videos. I'd greatly appreciate a like on this video, and please do consider to subscribe. Thank you. In today's video, we'll be going through the process of how to convert from polar to Cartesian equations, as well as how to convert Cartesian equations into polar equations. Well, the first thing we need to remember are our base equations, which as you can see are x equals r cosine theta, y equals r sine theta, r squared equals x squared plus y squared, as well as tan of theta equals y over x. Now let's go ahead and do some practice problems using these base equations. Well, the first practice problems we have say that we are converting between Cartesian and polar equations. Well, now we have our first problem, which says x squared plus y squared equals 64. Well, let's go back to our base equations, see if anything matches up, or we can substitute anything to do this equation. Well, we can see that r squared equals x squared plus y squared, so we can substitute our x squared and y squared for r squared. So our new equation will look like r squared equals 64, and we just need to isolate r. So we know r equals 8, because we take the square root of both sides. The square root of r squared equals r, and the square root of 64 equals 8. So that means we have r equals 8, and that is our answer for number 1. Now let's go ahead to number 2. Well, number 2 says y equals -2. Well, if we go back to our base equations, we know also that y equals r sine theta. Well, let's go ahead and substitute that in and see what we get. So now we have r sine of theta equaling -2. Well, now again, we want to isolate r because we are converting into a polar equation where r is our main value. So we're going to divide both sides by sine theta, or multiply both sides by 1 over sine theta, whatever you feel is easiest for you. So I'm going to do division. So we're going to divide both sides by sine of theta. So those eliminate on our left side. So we're left with r equals -2 over sine of theta. -2 over sine of theta can also be written as r equals -2 times 1 over sine of theta. As we should know, 1 over sine theta is equivalent to cosecant. So we have r equals -2 cosecant, also known as CSC. So that is our final answer for number 2. Now let's go ahead and do number 3, which says x equals 5. Let's go back to our base equations again and see if we can substitute anything for x or 5. Well, if we look at our base equations, we know that x right here, our first base equation, equals r times cosine of theta. So let's go ahead and substitute r cosine theta for x. For problem number 3, well, we have r cosine of theta equals 5. Again, we want to isolate r. That's the main thing we're looking for a polar equation. So let's go ahead and divide by cosine of theta on both sides. We divide by that. So we get r equals 5 over cosine of theta. Or you could have been multiplying by 1 over cosine, whatever is easiest for you. So this is basically just r equals 5 times 1 over cosine of theta. As we know, 1 over cosine of theta is just secant. So we have r equals 5 secant theta. And we should also add the theta for number 2, theta. Those are our answers for 2 and 3. Now let's go ahead and do number 4. Well, number 4 says x minus 4 squared plus y squared equals 16. Well, again, in this type of equation where it's polar, we need to just isolate the r value. Well, we can see that we don't have an r value just yet. Well, what we do need to do is expand this x minus 4 squared right here. Well, we know x minus 4 squared is just x squared minus 8x plus 16. That's in our parentheses. And then we're just adding y squared and then equals 16. Subtract 16 from both sides. 16 minus 16 is 0. 16 minus 16 is 0. Well, the equation that we are left with, or our new equation, is now x squared minus 8x plus y squared equals 0. Well, now what we need to realize is that we have an x value in our equation by itself. Well, let's go back to our base equations and see what x equals. Well, we said x equals r cosine of theta, so we can substitute that in for our x. So now we're going to have x squared. I'm just rewriting the whole equation. We're going to have x squared minus 8r cosine theta plus y squared equals 0. Well, now we brought the r into our equation, and that's what we need to isolate. Well, again, we just did this by substituting the value of x from our base equation into this equation right here. Now, we have x squared minus 8r cosine theta plus y squared equals 0. Well, now we also know that in our equation, we have x squared right here, and we also have y squared right here. So then we have x squared plus y squared, and as we know in our base equation, that this equals r squared. Well, that means that we can just substitute this in for r squared, so we have r squared. So this means we really have r squared minus 8r cosine theta equals 0. We can see that both terms have an r. We can factor that out. So we have r times r minus 8 cosine of theta equals 0. And we just did this by taking out the r. Well, if we divide r squared by r, we have r. So that's why there's an r here. And if we divide the 8r cosine theta by r, we have 8 cosine theta. And so we just took the r right here. Well, now what we can do is we can say that, hey, we're going to use zero product property. So zero product property. And we can say that r equals 0 because this r. And then we have this r minus 8 cosine of theta equals 0. Now we just need to isolate for r. So we know r equals, add 8 cosine theta to both sides. R equals 8 cosine theta, and that's our answer for number 4. Finally, let's go to number 5 for the Cartesian two-polar problems. Well, 5 says we have x squared plus y squared equals 5y. Well, we know that x squared plus y squared equals r squared, as we can see in our base equations, x squared plus y squared equals r squared. Okay, so we have r squared equals 5y. Well, now what we can do is set this equal to 0. Well, what we can do is r squared, subtract 5y from both sides, and this all equals 0. Well, now, we know that y, if we look at our base equations, we know that y is equal to r sine of theta. So we can substitute r sine of theta for our y value in this problem. So we are left with r squared minus 5r sine theta. Let's see on. Sine theta equals 0. And we can see, again, we have both r's. We can factor out r like we did in problem number 4. So we have r times r minus 5 sine of theta equals 0. Now we're going to do zero product property one more time. And we say r equals 0 and r minus 5 sine theta equals 0, add 5 sine theta to both sides, and we're left with r equals 5 sine theta, and that is our answer for this problem. Now we are going to go ahead and do polar to Cartesian conversions with the same types of base equations. And now we're just going to be working backwards. Well, number 1 says we have r equals 5 sine of theta. Well, since we're going to a Cartesian equation, what we need to do is get an x and a y and try to get rid of that r. Well, what we need to do in this one is we can see that we have something really, really close to that our y value equation, which was y equals r sine theta. Well, here we have 5 sine of theta. Well, if we have an r right here, we would be able to substitute in our y value, and that would make it much easier. Well, we can do that. We'll just multiply both sides by r. So we have r times r, so we have r times r equals r times 5 sine of theta. And this would lead to r squared equals 5r sine of theta. And again, we said y equals r sine of theta in our beginning, and I can show you right now. We said y equals r sine theta. Let's go ahead and substitute in y for our sine theta value, or our sine theta value now. So we are left with r squared equals 5y. Let's go ahead and set this equal to 0. We're going to get r squared minus 5y equals 0. And we also know that r squared is equal to x squared plus y squared. So we have x squared plus y squared minus 5y equals 0. Now what we have to do is try to set this equal to 0, right? Well, what we need to do is complete the square. So we have x squared plus y squared minus 5y. And our third term is going to be our b value, or 5 for the y's, our 5 or negative 5 over 2. So we have minus 5 over 2. And remember, when completing the square, you have to just square this third term and add it to both sides. And remember, this is equal to 0, so we can just add what we just squared. So negative 5 over 2 squared. And so we should be left with x squared plus y squared minus 5 over 2 squared equals negative 5 over 2 squared is just 25 over 4, so we can have equals 25 over 4. And then we can see that both terms in our parentheses are squared, so we can go ahead and rewrite that. So we have x squared plus our whole parentheses squared, basically. So we have y squared minus 5 over 2. So we have y minus 5 over 2 squared equals 25 over 4. And then this is your final answer for problem 1 on polar to Cartesian conversions. Next, we have the problem which says r equals 5. Well, if r equals 5, well, if we remember that r squared equals x squared plus y squared, we know that r equals the square root of x squared plus y squared. So this just means that 5 equals the square root of x squared plus y squared. But remember, it's not just going to be 5 because we squared our r. And since r equals 5, it's really going to be 25. So now we have 25 equals the square root of x squared plus y squared. Well, now for number 2, we need to remember that r squared equals x squared plus y squared. Well, if you remember that r squared, so we have r squared equals x squared plus y squared. Well, we know that we have r equals 5. So if we square 5 and r, we'll be able to get this equation. So let's do that. So we have r squared equals 25. Since r squared equals 25, we can substitute that in to this equation right here, which is one of our base equations. So we have 25 equals x squared plus y squared. Well, we need to isolate for y squared. So what we do is we do 25 minus x squared equals y squared. Well, now the only thing we have left to do is to take the square root. So we take the square root of both sides. So we need to isolate y. So we have y equals the square root, because we take the square root of y, equals the square root of 25 minus x squared. We know that if we take the square root of 25, we get 5, and we take the square root of x squared, we get x. We have minus x equals 5. 5 minus x equals y, and that is our final answer for number 2. Finally, we have number 3, which is r equals negative 4 cosecant theta. Well, we said that cosecant, CSC, equals 1 over sine of theta. So in reality, we have r equals negative 4 times 1 over sine theta. Now, what we need to do is get our value. Well, we know that if we multiply both sides by sine theta, we should be able to get helped. So we have multiply by sine theta over sine theta. So we have sine theta over sine of theta. Well, we have to multiply both sides by sine theta. So we have r times sine of theta equals -4. And remember, we said that our sine of theta is just equal to y. If we look back at our base equation, scroll all the way up, we said our sine of theta equals y. Well, that's what we just got. So that means we know that y equals -4, and then that's our final answer from going from a polar to a Cartesian equation for this last part. Well, I hope this video helped, and if you believe it did, please consider to like and subscribe. I would greatly appreciate it. We have passed 100 subs. I greatly appreciate all the support the channel has been getting. Thank you guys so much. Again, please comment and like if this video helped. Hit the bell notification button for future updates, and definitely follow the Instagram. Thank you. In today's video, we'll be going over the various applications of parametric equations. Well, problem number 1 says that at noon, a runner starts 1 mile north of her house, and at 1 p.m. she is at a point that is 5 miles east and 4 miles north of her house. A asks, how far has she run in her first hour? Well, from noon to 1 p.m. is 1 hour, so we're trying to find how far she went from the 1 mile north of her house to the next point at 5 miles east and 4 miles north of her house. Well, I like to start off this question by drawing a diagram. So we can say that this orange box is our house, and we can label H. Then we can use red. And then we know that she is 1 mile north. So we're going to say that this line segment is A, which is 1 mile north, right? So she's currently here at noon. So I'm going to write a nice little 12 right next to it. Sure. She's here at 0 hour, okay? Well, then we know that at 1 p.m. she's found to be 5 miles east and 4 miles north. So let's go ahead and write that out. Well, let's use a little lighter of a blue. So 5 miles east. So 5 miles east. So let's go 5 miles east. So let's say that is 5 miles. This is going to be segment B. 5 miles east and 4 miles north. So here's her house, and she's 4 miles north of that point. Well, so let's just say this is 4 miles. 4, and this is also segment B. Well, now we know that she is currently here at 0 hour. So it's going to be hour 0. This is going to be hour 1. Well, what we need to find is how far she traveled from right here to about right here. Well, what we're going to do is use Pythagorean Theorem. So we can make this a nice little triangle, and we know that this is the 5 east, and she was found 4 north. If we know that this part right here is 1, so she's already right here, but she was found 4 miles north. That means she traveled another 3 miles north in that 1 hour. So from this segment to this segment, she traveled 3 miles. So now we know that this segment is 3, and we know that this bottom segment is still 5. And now we need to find our hypotenuse, which is the total distance that she traveled in her first hour. Well, what we need to do is Pythagorean Theorem. And hopefully all of you remember Pythagorean Theorem is a squared plus b squared equals c squared. So what we're going to do is use 5 as a. So we have 5 squared plus b squared. B is 3, as we said, plus 3 squared equals c squared, and c squared is our hypotenuse, or c is our hypotenuse. So then we have 5 squared, which is 25, 3 squared, which is 9, equals c squared. 25 plus 9 is 34. The square root of 34 equals c. Well, now that we know the length, we know that in her first hour, she traveled a distance of the square root of 34 miles. So now what we're going to do is, we know that she traveled the square root of 34 miles in her first hour. And we know that we cannot simplify the square root of 34. Well, that means our answer is she traveled the square root of 34 miles in first hour, and we're going to leave it in radical form because that's the most accurate. Let's say your answer for another type of problem was the square root of 44. What you could have done is done 2 square roots of 11, because we know that 2 squared is 4, and 4 times 11 equals 44. So you always want to use the simplest radical you can in your final answer, and we are going to leave it in radical form, as I said before, because it is the most accurate. Well, now let's go to 1b. It says that if she continues at this pace, where will she be in relation to her house at 2 p.m.? Well, now we know that she traveled an additional hour. When I was working through this problem, I actually skipped it and went to problem C, because in problem C it says write a function that will give the runner's position at any given time. Well, we know her position at time 0, which is at noon, and we also know our position at 1 p.m., which is t1, or our first hour. So what we're going to do is make a chart in order to write our functions. Well, our chart is going to consist of three different variables, which are t, x, and y. So t is basically representing our time. So we know that we have our times of 0 hour and hour 1, and we need to find hour 2 for part B. But let's finish up 0 and 1 first. Well, we know at 0 we need to find our x and y. Well, x will represent our horizontal axis, which is east and west. So whenever we see east and west, we know automatically that that's going to be dealing with our x value. So we have east, I'm going to write E and W. Then y, it goes up and down. Well, we know up is north, and then down is south. So whenever we see y, we know that it is N or S, north or south. Well, now what we need to do is find those values. We're going to go back to 1a and see where she was at 0. Well, we know from our problem, it states that at 0 or at noon, she was only 1 mile north. It doesn't give us any information if she was east or west, so we're going to assume she was just exactly 1 mile north of her house. So we know our x value is going to be 0 because we have no east or west, so that's 0. But we do know that she's 1 mile north, so y is 1. Well, then at 1 hour, which is at 1 p.m., because noon is 12 p.m. to 1 p.m. is 1 hour. And the problem also tells us that at 1 p.m., she's 5 miles east and 4 miles north of her house. So 5 miles east, that is our x direction. So we have our x equals 5. But then we know that at y, or north or south, she's 4 miles north. So we're not going to be adding 1, because remember, we are just 4 miles north. So our position is exactly at 4. So we have a y value of 4. Well, now what we need to do is get the equation. Well, in order to get the equation, there's several ways to do it. And one way I like to do it is where we have x equals y, or x equals a1 plus w times t. Well, what we have to do here is a1 is going to be our first point in our x, because this is the x equation. So then we have 0 plus w, which we don't know, it's the variable which we're going to solve for later on in this problem, w times t equals x. But you can see that our next point, 5, 4, which we have right here, can be used to help solve for w and complete our x equation. So what we're going to do, we're going to substitute that in. So what all we need to do is deal with our x, because this is an x equation. So we know x is 5, so when 5 equals 0, a1 is going to stay the same, plus w, and we're going to look at the t at this value of 5, which is right here. So our t value at 5 is 1. So now we just need to isolate w. Well, w times 1 is w, plus 0, it doesn't really matter, 5 equals w. So now we know our equation. So we're now going to substitute this guy back into the equation where we didn't know w originally. So now we know x equals 0 plus 5. Oh, ran out of space. So now we know x equals 0 plus 5t. That is our x equation. But now we need to find the y equation, because it's going to be a parametric function. Well, for a y equation, it's the same exact thing, but we're going to deal with our y values. So we have y equals a1 plus w times t. You can make it a b, you can make it another variable if it helps you remember that one is for x and one is for y. But at the end, it's going to be the same thing. But so now we have y equals, our a1 for y is 1 plus our w times t. Well, our w value is unknown, so we have w times t. We're going to do the same thing where we go to our next y values, which is 4, equals 1 plus w, and our t at 4 is 1, w times 1. Subtract 1 from both sides, 4 minus 1 is 3, 3 equals w. So now we know that. We're going to substitute this back into our original equation, which was y equals 1 plus 3 times t, and that is our y equation. So we know our x equation was 0 plus 5t, and our y equation is 1 plus 3t. So our answers are the ones that I'm about to highlight. Let's make it a nicer color. So we know this is one of our answers, and this is another one of our answers for problem C. Now coming to number 1b, we are going to use the equations we just found in part C, and we're going to apply them to B. Well, in part C, we found that x equals 0 plus 5t, and then at y, we have y equals 1 plus 3t. Well, we know that we need to find out where she is in relation to her house at 2 p.m. Well, that's why we wrote this extra row at 2, because that's our second hour that she has traveled. Well, at 2, we're going to find our x and y value, and that's easy since we already found our equations. So we're going to substitute 2 into our x equation and then our y equation. So let's just write it up here. So we know x equals 0 plus 5t, and y equals 1 plus 3t. 1 plus 3t, and t equals 2 because it's the second hour, and t represents time. So now let's do that up here. Well, t equals 2, so we have x equals 0 plus 5 times 2. 5 times 2 is just 10. 0 is nothing. X equals 10. Then we have y equals 1 plus 3t. Y equals 1 plus, and we substitute 2 for t, times 2. 3 times 2 is 6, plus 1 equals 7. Y equals 7. So we can write that down here. Y equals 7. Alrighty. Well, now we know x is east and west. What I do personally is I consider west to be negative and east to be positive. Well, now what we can do is we can say, hey, we have both positive numbers. So we know that x is east and west. So we know that we are 10 east of the house, of her house. And then we need to see that we have a positive y. And remember, y is north and south, north and south. I consider north as positive and south as negative. We have a positive number. So we know that she is 7 north of her house. And that is how you complete problem 1 for this video. The rest of the video will be coming in part 2, which will be uploading soon. Thank you. I hope this video helped. If you believe it did, please consider to like and subscribe. Also, our Instagram is in the description below. You'll get all the new updates for our new videos. Thank you. In today's video, we'll be looking at part 2 of applications of parametric functions. Do the same thing we just did, or are we? Because now what we're going to do is we have a base equation for this question. And that base equation, which you should have in your notes, is HO plus VO, or V naught, sine of theta times t minus 1/2 gt squared. That's the base equation. Well, we need to split it into components. Remember, we have an x and y value, so we can split it into components. Well, if we split it into components, we get x of t, so that's our first base equation, is VO, or V naught, however you like to say it, V naught plus cosine, well, V naught times cosine of theta times t, and y of t equals h naught plus VO sine theta times t minus 1/2 gt squared. If you are in physics, you know that g should be negative 9.8 or positive 9.8 meters per second. In math, they use 32 feet per minute squared for g. So now what we need to do is substitute the values we know in our question into this equation. We already have our x and y components, so we're just going to substitute. So now we know our initial velocity is 62 feet per second. So now we have 62 times, which is our initial velocity, 62 times cosine of theta, or as our angle, which is 45 degrees. And that's it, times t. Well, now what we can do is we can look at our unit circle and say, hey, the cosine of 45 is, we can say that the cosine of 45 is about square root of 2 over 2, square root of 2 over 2, okay, and we know that's t, and we know it's cosine because cosine is the x and sine is the y. So we know square root of 2 times 2, but remember we have that 62 in front. So your x equation, you don't really have to simplify it. This is the simplified form, x of t equals 62 times the square root of 2 over 2 times t. And that is your answer for the x of t. Now let's do our y of t. And if you remember, we wrote down the y of t equals h naught plus v naught times sine theta t minus 1/2 gt squared. Well, now what we do is we can substitute again. And let's use a different color now. So we know that h naught, h is representing your height, your initial height, that's why there's a naught. So you have 50 plus VO we said was 62 feet per second, plus 62 times sine of theta, sine is our y value of theta is still 45 degrees, times our t value, minus 1/2, and we said g is 32 feet per second. I'm just going to use 32, and then we minus 1/2 gt squared, so we use 32 times t squared,
Okay, well now we can simplify this down. We know that sine of 45 is also square root of 2 over 2, so square root of 2 over 2 times 62 plus 50 minus 1/2 times 32 is 16 times t squared times t squared. And this essentially means we have 62 times square root of 2 over 2. Well, if we want to divide by 2, we can do that pretty easily. Well, 62 divided by 2 is 31, so we can rewrite the equation 50 plus 31 square roots of 2 plus or square root of 2 minus 16t squared y of t equals, and that is our second equation. And so the equations for our 5a question are this x of t right here and this y of t right here. Let's combine those equations and put it up top so we can do b. Now that we have the work from the previous question moved out of the way, b says the football reaches its maximum height at t equals 1.37 seconds. Using your parametric equations from part A, which we just got, determine the location of the football at its maximum height relative to the starting point. Well, if you remember, we have a t in our questions. If you remember, we have, well, as you can see, we have a t in both of our equations, so we can just substitute in that 1.37 seconds for t. Pretty simple stuff. You can do this in your calculator, or you can do it by hand. There's also a t after 50 plus 31 times the square root of 2. There's a t right here, because we had a t in our base equation right up here for y of t. So we're going to solve for our y value now. Well, for the y value, we're going to substitute 1.37 in for t, and we have two t's in this equation, so we can just do that in our calculator or by hand, whichever is easier for you. And after substituting in 1.37 for t, we get an answer of approximately 80.03, and we know this is the maximum height, meaning it's going to be above the starting point because the question is asking relative to the starting point. So we're going to call it 80.03 above starting point. All right, now let's go ahead and do the x equation. Well, the x equation is 31 times square root of 2 times t, and we should get a value of 60.06 in the x direction, and then this 80.03 is going to be in the y direction. Okay, now that's how we would do number 5a and b. So our equations were y of t equals 50 plus 31 times square root of 2 times t minus 16 squared was 31 times the square root of 2 times t. And then we use those equations in order to solve b. And the last question for this video, it tells us that we are on a Ferris wheel that has a radius of 50 feet, and the bottom of the wheel is 3 feet above the ground. The Ferris wheel starts when you get on at the bottom and rotates counterclockwise, and has a period of 3 minutes. Create a parametric function to model your location on the Ferris wheel at a given time. It goes counterclockwise. Well, we know a clock goes this way, then goes like this. This means that the Ferris wheel goes this way every time it moves, going opposite of a clock. Well, to start this problem, I personally would draw a diagram just to get a good understanding of where we are on the Ferris wheel. So if we look at it, a Ferris wheel, let's say it's a circle, and then we know that we're 3 feet off the ground. So let's say that the platform is from here to here, and that's 3 feet. Since it's a circle, and they told us that we have a radius, and we know the radius is 50 feet. 50 feet. And we know that the period is 3 minutes. Period is 3 minutes. P equals 3 minutes. And now we need to find the parametric functions. Well, again, we're going to make a table of our 3 variables, as you should know by now, which are t, x, and y. Let's go ahead and write that down here. We have t in our first column, then x, then y. For our t, we know that we have a radius of 50. Well, now we want to divide 180 by 4, and we know our first point is going to be 0, so we're going to have a total of 5 t values, first being 0. So 180 divided by 4 is about 45, so we'll have our first real point after 0 at 45, then 90, then 135, and then finally back at 180. Let's go ahead and label the rows then in our table. We have 0, then 45, 90, 135, and then finally 180. Now we need to find the x and y values, which we are going to use the information provided in order to find. Well, what I like to do is call this central point our starting point. We're not in any type of box. We really don't have to worry about stuff like subtracting or adding. Well, now that we know our t values, we're going to try to figure out our x values. Well, we know that this 50 can act in both our x and y direction, but the 3 feet is only acting in our y direction. So our t of 0, so t of 0 is right here at our starting point. I'm going to call that central point the starting point. We need to find the x that we traveled. Well, we really haven't traveled any x. We haven't gone left. We haven't gone right. We're just at the center. So our t is going to be 0. But our y, we're always 3 feet above. So if you think of this as 0, 0, it's really 0, 3 because we're 3 above our origin or 3 above the ground. So we're going to call y 3. Well, we know it takes a total of 180 seconds or 3 minutes to complete one whole period or one revolution of the entire Ferris wheel, which now we need to divide into 4 segments. And we know it moves counterclockwise. We drew how a counterclockwise object moves. So we're going to say it starts here. And the first point is going to be right here at 45. This is going to be when it's at 45 seconds after the beginning point. Well, we can see that it moved from our central point to the right about 50. Well, it moved to the right, and since we're going counterclockwise, it's technically becoming negative. So we're going to go 0, and then we're going to call this traveling negative 50 this way. We're going to call right negative 50. So we have negative 50 because we know the radius is there. We're at our center. From our center, we went right 50 feet since that is our radius. So we went negative 50 in our x direction. But how about our y direction? Well, at our y direction, we're starting at the origin, but then we have to go up about halfway of the circle. But we know that the 50 feet is the radius, meaning from any point to the center in the circle, it's going to be 50 feet. So if we thought that the 50 feet starts from right here at our origin to the middle, and we can see the middle lines up with our 45. That's how high we went. Well, if we add 50 plus 3, we get 53. And that's going to be the y value for 45 t. So we have 53 as our y. Let's go ahead to 90. Well, we know 90 is right after 45. We're going counterclockwise. We're going this way. 90 is right up top. You can also look at this as the unit circle. So we have 90 up here. Now, at 90, we can see that our x really hasn't moved because we're still at that x point right at the center in our origin where the x hasn't gone left or right. We're just going straight up. So our x is going to be 0. There's no moving left or right. But in our y, we can see that we went up a significant amount. We're at the top of the circle. Well, we know the radius goes half the circle, right? But we're at the top, so we're double the half. Well, if we double our radius, we'll get our diameter, which is the entire length of the circle. And if we double 50, we get 100, meaning that the diameter of the circle is 100. But that's the top. But we have to remember that we are raised 3 feet. So we have to add 3 feet to our diameter. Well, our diameter we said was 50. We're just multiplying our radius by 2 because we're going double the half length to get to 90. So 50 times 2 is 100. 100 plus the amount we're raised, which is 3. 103. Next, we'll go to 135. Well, 135 is right here. So 135 at x, we know that we move left. Well, since it's a counterclockwise direction, that is going to be our positive. And since we know our radius is 50, we know that we are still at origin, but then we moved left 50. So we moved left to the edge of the circle to 135. That means we traveled 50 in our x direction, and it's positive since it's going left. Well, now we know that our y, we moved up to the middle of the circle, and our y should be the same as 45 because we can see that they're aligned. Well, now, what was our y? How did we get it? And our y, we know that the radius is 50, meaning from any point from the edge of the circle to the center is going to be 50 feet. And since we know that from 135, or this edge to the center is 50 feet. That's how we got x. But since we're looking at our y, we know that this segment from the center right here, or to the edge of the circle, is going to be 50 feet as well. And then we'll raise 3. 50 plus 3 is 53. That is our y value of 135. Finally, we're going to do our t value of 180. Well, if you remember from the clock question, the first and last coordinate points for a circle should be equivalent, and they are the same in this case. They're going to be equivalent, which is 0 and 3, because we know 180 is going to be right here. So we didn't move any x, we didn't move any y, except the raised part, which is 3 feet. Now that we've completed our table, it is time to find the parametric functions that accurately illustrate or describe this scenario with the Ferris wheel. Well, to do that, let's look at our data. Well, there's something interesting in our data. You can see that x starts at 0, goes to negative 50, goes back to 0, goes to 50, and then goes to 0. Well, this is pretty similar to a sine function, which starts at the origin, goes to the maximum, and then the origin, and then the minimum. Well, you can see it's reversed. It's going from the origin to the minimum, back to the origin, and then to the maximum, meaning that it's going to be a negative sign. Well, pretty easy stuff. So we're going to have our x of t equal our starting point, or our origin, which is 0, plus our amplitude. We can see we're going up 50 and down 50. Or you could do the equation, which is y max minus y min over 2. Well, we can see our y max, or in this scenario, is going to be our x max and our x min. So we can see our x max and x min. So our x max, we can see is 50, and our x min is negative 50. So we have 50 as our max minus negative 50. 50 minus negative 50 is 100. 100 divided by 2 is 50, meaning our amplitude is 50. So 0 plus 50, well, we said it's a negative sign, so we can do a subtraction. So minus 50 times sine minus sine, and then here we're going to put our period. Well, our period we said was 3 minutes, and we know that, well, this is going to be your b value, and we know b equals 2 pi over your period. We said period is 3 minutes. Well, we're going to take this in minutes. We have b equals 2 pi over 3, and that's going to be what's in our parentheses, 3, and this is going to be all multiplied by t, because it's a parametric, and t is going to be a variable, so you can use this equation to find it at any point in time. Finally, we're going to do our y equation. So we have y of t, same process, but let's look at our data. We start at 3, we go to 53, then we go to 103. Well, we can see we're at pretty low in the spectrum, because at the end we return to 3 again. So that means our center point is somewhere at 53. Well, if we're starting at the bottom, we know that cosine starts at the max, goes to the origin, and then goes to the min. Well, we're starting at the min, going to the origin, and then going to the max, meaning it's a negative cosine. So we're going to do the same thing. Well, we're going to first find our c value, which is this value basically. And the equation for our c value is c equals y max plus y min over 2. We can do it for x of t if you don't know how to get it, because we have our min of negative 50. So we have negative 50 plus our positive 50, which is 0. 0 divided by 2 equals 0. That's why we got a c value of 2 for x of t. Now let's do the same thing for our y equation. Well, we have a y max of 103. So we have 103 plus our y min, which is 3. So we have 106 over 2, which means we have a c value of 53. So that's where our center line is. So that's where our c value is. Next, we have to find our amplitude. We said amplitude is y max minus y min. So we have y max minus y min. We said the max was 103. The min was 3. 103 minus 3 is 100. Divided by 2 equals 50. So we know the amplitude is 50. We said it's a negative cosine because it starts at the min, goes to the origin, and then goes to the max. So we have minus 50. We said we got 50. Cosine, same period, 2 pi over 3 times t. And that's basically it. This is the final answer to this last question. I hope this video helped. If you believe it did, please consider to like and subscribe. I would greatly appreciate it. We have made an Instagram, which should keep you updated on our latest videos. Comment below for any future video recommendations. Thank you. In today's video, we'll be looking at part 2 of applications of parametric functions. Well, now question 2 is asking to create the parametric function that would model the endpoint of the second hand. As we know, the second hand is the longer hand on the clock. Well, what we need to find is the parametric function which will model this endpoint right here. Well, we are given some dimensions, which are 6 centimeters in our y-axis, 5 centimeters in our x-axis, and in the clock we can see we have 4 centimeters. We are also given the information that the period of this function is 60 seconds. Well, we can also say that it's 1 minute. So now what we want to do is start to try to find the parametric function. Well, as we did in question 1, we need to make a table in order to help organize our data. Well, let's start out with doing that. And if you remember from part 1 of the video, which will be linked, and you can see the info card in the top right corner, we need to have 3 different variables, which are t, x, and y. So let's make it right here. So we have t, then we have x, and then we have y. Well, we can see that on a clock, there are basically 4 or 5 main time segments which we remember in our heads, which are 0, 15, 30, 45, and 60. As you can see, these are in increments of 15. When we tell time, we often say it's a quarter till 5, or it's a quarter past 5. So now, a quarter of an hour, a quarter of 60 is 15, and that's why we're going at increments of 15. Well, we're going to divide our table up like that into nice segments of 15, and remember, t is going to be our time again, in this scenario as well. Time. X is going to be how far we travel in the x direction, and let's denote it actually. So what we can do is we can highlight x as being orange, and we can highlight our y as being, let's try a different color, let's try purple, and y as being purple. So we can do this, and we said that x is orange. So you can see that the 5 centimeters is now orangish, and the 6 centimeters is purplish. Well, we can also see that this 4 inside can act as a 4 going this way, or it could be a 4 going up, meaning it can apply to both our x or y directions, so we're not going to mark it any color just yet. Well, now, we need to see what our x value is when t equals 0. So t equals 0 on a clock is basically right up here on the top. So what we need to see is our starting point, well, our starting place for this question is going to be the bottom left corner of this picture. And you can see there's a box that is surrounding the clock, which will play in to our answers. Well, we need to find how far we traveled in our x direction, so this way, in order to get to this point of 0, essentially. Well, we can see that we traveled a total of 5 to the right from the edge of this box in order to get to the position of 0. So that means 5 is going to be our first x value. Now we have to find the y value. Well, we said the y is the 6 centimeters, and it's denoted in purple. Well, that means we need to see how far we went from this corner in blue or teal up to right here. Well, we can see that 6 goes from the edge of the box to about the middle of the box. And remember, we said that we're not going to the end of the box, but instead, the question's asking to the end of the second hand. So, we also know that we have a 4 centimeters inside. This is where that 4 centimeters plays in. So we go up 6, and we're about halfway there. We want to get till right here. So we want to go from here to about right there, which is the end of the second hand. This means that we need to add 4, as we can clearly see here. If we add 6 and 4, we get right to the end of our second hand. As we know, 6 plus 4 is 10, so our y value is 10. That's our first row done. Let's go ahead to our second one. And let's erase all these markings so we can clearly see what we're doing on the next one. Well, our next one, we have to look for 15. Well, 15 is a quarter past 12. So a quarter of the clock is right around 3. And remember, each number is an increment of 5, 5, 10, 15. So that means at 3 we can denote our 15 mark. So we have 15 right around here. So now we need to see how far we went from this starting point all the way till 15. So we can see we have 5 all the way halfway. And then, but if we had another 5, we're already at the end of the box. And we can see there's a clear distinction. Let's shoot it here. there's a clear distinction between the box and the end of the second hand. Well, now we need to see that if we traveled 5 already, and if we do add 4, would that work? Well, 4 would be around right here, right? So 4 would be around right here. And that would be exactly perfect where we need to be. Because if we had another 5, we would be at 10, but we would be at the edge of the box instead of being at the edge of the second hand. So let's just draw the second hand just for reference. We need to be about right here and not right here. Since we want to get here, we can just add 4 because we know that the length of this hand till the end is 4. So 5 plus 4 is 9. So we traveled a total of 9 for the second x value at 15 seconds. Or 15 minutes. At 15 seconds. Now we need to find the y value at that point. Well, we can see that from the starting point in the bottom left corner of the box up to this 3 mark right here, we know that we traveled about halfway up the box, and that if we measure this or we align it, we can see that clearly 6 is how high we went. And if we started at 0 here, we call this 0, we go up 6, that means our y travel, or our y value at 15 is 6. So we can write that in our table. So y is 6. Now we finished our second row. Now let's go through the third row, which is at 30. As we know, 30 is about at 6, because 6 times 5 is 30. That's way halfway through the clock. So this is 30. And now we need to see how far we went from the corner, the bottom left corner, to 30. Well, we can see clearly that it's 5. So 5 centimeters is our answer in our x direction in order to get to 30. Now we need to get the y value. Well, we can see that we don't go 6, we only go up till about right here. And let's just mark it really quickly. Let's mark it in blue. So we go till about right here, and we define the length. Well, we can see it's definitely not 6. We can see it's definitely not half of 6. So what can we do? Well, we know that half of the circle, or half of the clock, is 6 centimeters up. But we also know the length of this is 4 centimeters. And if we find the difference, we will get that difference where we stand, which is about right here. So we went from here to here on the box, which is definitely less than 6 and definitely less than 4. So if we go up 6, so we're going to be right here, and then we subtract our 4. So if we subtract 4, we're left with this portion. Well, if we know that this much is 6, and that's 4, 6 minus 4 is 2, we know that this line segment is 2. So we know the next y value at 30 seconds is 2. And again, let's run over that and make it a little more simpler. Okay, so we go up half, but we're not quite at half because we're down here at 6. If we say that it's 4, it's not 4 because we don't travel a total of 4 up. We're traveling from this corner and we need to get to only about right here. This is the goal right here. If we travel 6, we're up here. And if we travel 4, we're about right here. So now what we need to do is we can see that at 6, we are too high, and at 4, we're too low. If we take the difference of these two, we will see that we will get the value going from about here to here, which is exactly what we need. So now we know that 6 minus 4, 6 and 4, 6 minus 4 is 2, and that's how we got our y value of 2. Well, now let's go to 45 seconds. Well, 45 seconds because 9 times 5 is 45. And now what we need to find is the x value. Well, we travel a total of 5 here, but we're definitely not at 5. We're only right here at 9. So what we need to do is see that we traveled 5. It's too much. If we traveled 4, that's not enough. So now we take the difference of the two, and then we get 1. So our x value here is 1. We traveled 1 from the edge of the box, which is right here. So we went from here to here, and that's about 1 because we do 5 minus 4 because we traveled 5, but then we go back 4, and then we get a leftover 1 since 5 minus 4 is 1. That is 1 for our x value at 45. Let's find the y value. Well, we can see that we go up 6, and exactly at 6 we're at 9. Pretty easy. We are at 9. Next, let's go ahead to 60 seconds. Well, Well, 60 seconds and 0 seconds are at the same place on the clock, so they have the same coordinates, which are 5 and 10. Well, now we have our table set up, so we just need to make the equation. Well, to find the equation for our table, we need to think about a sinusoidal equation since we're dealing with a circle. Well, if we remember, the base equation for a sinusoidal was y, or x, equals c plus a sine or cosine, depending on the scenario, times 2 pi over our b, or our period value, times t, since it is a parametric. Well, let's look at our x first. So we're going to write x equals, we know it's c plus a. Let's try to first figure out if it's sine or cosine. Well, if we remember, a sine equation or a sine graph starts at the midline or origin, goes to its max, goes back to the midline or origin, goes to its minimum, and then back to the midline. Well, we can see that we start at a value of 5, we go up to a value of 9, we come back to a value of 5, we go down to a value of 1, but then we come back to a value of 5. We can definitely see that 5 is our midline or origin, and we keep coming back to it. And we do start at 5. And that is why this equation for our x is going to be a sine equation. So we have a sine of our 2 pi over our period times t. Well, we were also given that our period was 60 seconds. So let's go ahead and substitute that into our equation. So then we have x equals c plus a sine of 2 pi over 60. We know that 2 pi over 60 can easily be simplified down to pi over 30. Let's do that really quickly. Pi over 30. And it's all being multiplied by t. Let's figure out c in our a values. Well, we know c equals y max plus y min over 2. And we did this in our last video for the next problem. And then we also know that a equals y max minus y min over 2. Now, let's go ahead and find our values. Well, let's do this first. So we know a equals, and we're going to do our x, so it can be x max and x min. Well, we know our x max is 9, so we have 9 minus our x min, which was 1, 9 minus 1 over 2. 9 minus 1 is 8, 8 over 2 equals 4. This means our a value equals 4. So let's go ahead and put that into our equation. So x equals, let's leave c blank for right now, plus a, and we just found out a equals 4, times sine of pi over 30 times t. Let's go ahead and find c. We just said c equals y max plus y min over 2. We know y max was 9. And this is coming from right here in our table, plus our y min, which was 1 over 2 equals 10 over 2, which equals 5, meaning c equals 5. And we can just put that into our equation. There we go. We have our x equation for our parametric. Now let's go ahead and find our y equation. We're going to use the same base sinusoidal equation, which is y or x equals c plus a sine or cosine times 2 pi over b, or our period, times t. Well, now we have to go ahead and do y. So we're going to look at our y table, or our y column in our table. So we have y equals c plus a. Let's go ahead and do c and a. Well, we said c equals y max plus y min over 2. We can see that our y min is 10, and our y min is 2. So we have 10 plus 2, so we have 10 plus 2 over 2 equals 12 over 2 equals 6. So now we know our c value is 6, and we can just substitute that into our equation. 6 plus our a value, and we said our a value is y max minus y min over 2. So we have 10 minus 2 over 2. 8 over 2 equals 4, and that is our a value. So we have 6 plus 4 for the first part of our equation. And then let's look at the data and let's determine if it's sine or cosine. Well, we can see that we went from 10 to 6 to 2 to 6 and back to 10. So we started at a maximum of 10. We went down to 6, then we went down to 2, we went back to 6, and then we went to 10. So 10 is our maximum, 6 is going to be our midline, 2 is our minimum. So we started at the max, went to the mid, to the min, back to the midline, and then to the max. That sounds really similar to a cosine equation. So we have 6 plus 4 cosine. We have the same period, so it's still pi over 30, which was originally 2 pi over 60, got to simplify down to pi over 30, times t. And then this is our y equation. And that's how you'd complete this problem for 6.3.1, applications of parametric functions. If you believe this video helped, please consider to like and subscribe. I would greatly appreciate it. We've also created an Instagram for future updates and video notifications. You can also hit the bell icon for future video notifications. Comment below if you enjoyed this video. Remember to like and comment. Thank you. In today's video, we'll be going over how to use the derivative in order to find function information. To start off, we're going to find the derivative of our function g of x, which is 2x cubed minus 12x squared plus 18x. To start off, we're going to use the power rule in order to find the derivative, and if you want to know how to use the power rule, you can find it up here in the corner, or you can go ahead and check out the last video on the channel. So to start off, we are going to use the power rule, and we know by using the power rule that our derivative is 6x squared minus 24x plus 18. And we know that we can factor this. So if we factor it, it'll come out to 6 times x minus 3 times x minus 1. Okay, so now that we have our derivative, so we're going to just write that, hey, it's a pretty dark color. Hey, this is our first derivative. This is basically what we're going to be using for the majority of this video. So our first step is to find, the first step for these types of problem is to find the derivative, first derivative you could say. And our second step is going to be finding the critical points. And this is going to be from the derivative itself. You're just setting the derivative, I'm just going to put this in parentheses for reference. Derivative, you're setting the derivative equal to 0, and that is how you find your critical points. And then your third step is to sub values into derivative, and you'll see how these steps play into these questions. So let's go ahead and do our first problem, where it asks, is the function increasing or decreasing when x equals 5? So when you have a question like this, you're going to substitute this value, x equals 5, or this value of x, which is 5 here. You're going to substitute that into your derivative. And we said our derivative is 6 times x minus 3 times x minus 1. Substitute in our value of 5, as we said before. So this is where step 3 is playing in, subbing values into the derivative. So we have 6 times 5 minus 3 times 5 minus 1. So now we have 6. Now I'm just going to simplify the parentheses. 6 times 5 minus 3 is 2, times 5 minus 1 is 4. Let's finish up parentheses because PEMDAS. So we have parentheses, we have 6 times 2 times 4, as we know, is 8. 6 times 8 is 48. Now the main thing you want to remember, and I'm going to write it up here in orange, the sign equals increasing or decreasing. So basically, let's write it. So we have a plus. This means we have a positive number, positive value. After you substitute it into your derivative, this means you are increasing. And if you have a negative or a negative value, you are decreasing. That is something you should write down or try your best to remember when dealing with derivatives. Now we know that after substituting a value of 5 into our equation, that we get 48. And we know this is a positive 48. We had no negatives. So this means that our function is increasing, as we said here. When you have a positive value, it's increasing. So we have 48. So meaning our function is increasing when x equals 5. So our answer, let's write this in red. It is increasing because we have a positive value. That was easy enough. So let's go ahead and do B. And B is asking, find the interval on which g of x, which was our original function, is increasing. And here you can see that obviously we don't have a value like x equals this or x equals that. We just need to find an interval between this point and this point it's increasing, and at this point and this point it's increasing. So B and C have a similar process, that we must remember that the sign is what determines if it's increasing or decreasing. So let's write out the steps for this type of problem. So our first step is to find the critical points, and we're going to go through how to do that in just a minute. And then second is to make a timeline. make a timeline. Third, we are going to mark the critical points on the timeline. Mark critical points. And then 4, we are going to get values from all intervals. And you'll see what we mean in just a moment when we start B and C. From all intervals. 5 is to, oh, so weird, 5 is to substitute, and 5 is to substitute the values into the derivative. Okay, so let's go ahead and start B first and then go on to C. So to find the critical points, as we said at the beginning of the video, you're going to set your derivative equal to 0. So let's write our derivative down here, and we know our derivative, let's do this one in teal, let's just one in a light green. So we have 6 times x minus 3 times x minus 1, and we're going to set this equal to 0 to find critical points. So we're going to set this equal to 0. So this is just, we don't want to care about this that much, but we're going to set this equal to 0 first. So we have x minus 3 equals 0. Obviously that's 3. And then we have x minus 1 equals 0. And that is just 1. And if you just want to know how to do it, you're adding 3 to both sides, which leaves you with x, meaning that x equals 3. And here you're adding 1 to both sides, meaning that x equals 1. So now that we have our critical points, let's go to step 2, which says make a timeline. So let's make a timeline in blue. So let's make a timeline. So this is our timeline right here, pretty basic timeline. And here we're going to mark our critical points, as we said in step 3, mark critical points. Let's go ahead and do that. So we have a critical point of 1 and 3. So 1 is first, then 3. And whenever you're making your timeline for this type of problem, you must remember to include a negative infinity and a positive infinity. Those are going to be very important when dealing with these types of problems. And step 4 says to get values from all intervals. What this means is that we can see that we have an interval from negative infinity to 1, we have an interval from 1 to 3, and we have an interval from 3 to positive infinity. So you want to get some value that falls between each of these intervals. Between negative infinity and 1, I just called that interval number 1. Let's get a value from there. And let's just say that we chose negative 3 here. So let's just do this in this teal. So we have negative 3. And then for our second interval, let's just say we chose 2. And for our third one, we went from 3 to infinity. And let's just say we have the equation 2 cosine of 3t. So now in step 5, it's a substitute values into our derivative. Let's go ahead
Start
and
off,
do that.
we're going to divide 2 by both
I'm gonna move
sides
our
in order to get
critical
left with
points
cosine
calculations off to the side.
of 3t
Okay.
equals
Make that smaller.
negative 1 over
All right.
2.
So our derivative
we have cos
was
of 3t equals
6
negative 1
times
half.
x minus 3.
How I like to think of it is
times x
disregard
minus
the
1.
3t
Okay.
and just think about
So now
when does
let's go ahead
cos
and do
of
section
theta
by section.
equal
So interval number 1, we
negative
chose the value
1
of negative
half.
3.
And in
we
order to
just chose
find
a
this
value
out, we're going to
between
refer
negative
back
infinity
to our
and 1,
unit circle,
because that's our first
as we
interval.
can see right
So
here.
we have 6 times
Here,
negative 3
we have
minus 3.
cosine
We're just
and
substituting
sine.
our value we chose
Cosine is
into
denoted by our x
derivative
value.
as x.
So
Okay.
cosine
And then we have negative 3
equals
minus 1.
x, and
Okay.
sine
So we have 6
equals
times
our y value.
All right.
Now,
so then we have
just by looking at the
6
unit circle,
times
we need to
negative 6
identify which radians
times negative
have
4.
a cosine or
Remember,
an x
these are
value
parentheses, 6
of
times
negative
4
1
PEMDAS.
over 2.
We have
So now,
24.
looking at the unit
6
circle,
times
we can see
24
that 2
is
pi over 3
100
has an
and
x value of negative
4.
1 half.
And so
you can
now
also
that
see
we
that
know,
4 pi
remember,
over 3 has an
we
x
said that
value
the
of
sign of our
negative 1 half.
answer or the sign of our value is what determines
So
if
now,
it's
I'm
increasing or
going to
decreasing.
write both
We
radians
got a
off to the
positive
side.
144,
So we
meaning
determine
that in our
2
first
pi
interval, we are
over 3
increasing. And if you can find one of the intervals,
and
you should be able to
4 pi
know that they
over
alternate. So
3
we have positive, negative,
both have
positive,
a cosine
which you always want to check because
of
you can always
negative
make a
1
mistake in your
half.
calculations. So let's go
Next,
ahead and
what we're
put
going to
this
do is we're
calculation
going to look
the
at these
side.
2 radians right here, and we're going to bring it over here.
So now let's
Now
go
what
ahead
I
and
do is
interval
we
2.
can think
So we're
about
going to
it
substitute
like
2
this.
into our derivative.
We can
as
think
x.
about it as
So we have 6
3
times 2
of
minus
t
3 times
equals 3 of
2
t
minus
equals 2 pi over 3,
So this means, and remember PEMDAS,
and we
have
can also
6
think of
times
it
negative
as
1
3t
times
equals
1.
4
now we have
pi
negative 6
over
times
3.
1, which is just
You might be
negative
asking
6.
yourself why we did
negative,
this.
meaning it
Well,
is
we know that
decreasing.
3t, or the
Alright,
cosine
that
of
matches up
3t,
with what
is
we
going to
just
equal negative
did.
1/2.
Now finally,
And
let's
we
go
know
ahead
that
and do
3t
interval
is going to be
3,
equivalent
where
to
we
2
chose
pi
the
over
value
3,
5.
or
So we have
4
6
pi over
times
3.
5 minus 3
What I like
times
to do, just to
5
make things
minus
simpler,
1.
is disregard the pi
So we have
and add it
6
back at
times
the end.
2
So we can just think about this as simple
times
algebra. We
4.
have 3t
4 times
equals
2 is
2
8.
over 3.
6
Just disregarded the
times
pi. We're going to add
8
it back at the
equals
end.
48.
And we have 3t
And you can see
equals
that that was the
4
same value
over
we got
3.
up here when we did x equals 5.
Now, in order to get
And we know
rid
that's increasing
of the
because
3, we're going to
it's
divide by
positive
3
48,
on both sides.
and it all matches up. So now our answer
We divide 2
to
over
B,
3
let's
divided
just
by
write it
3.
right here. Let's move
We
this
get a
guy
total
and make it a little
of
smaller
2
here, and our
over
answer to
9.
B, we're going to write it
So
in red
this
again.
equals 2
So our
over
answer to
9.
B is
And again,
increasing
we said
from
we're
interval
going to
1
get pi
and
at the
interval
end.
3. So
we
interval
know
1
that
is
one
from
of our
negative
answers
infinity to
is
1.
t equals 2
So we
pi
know
over
that it's
9.
increasing from
Then we're going to do the
negative
same thing for
infinity
the 3t equals
to
4 over
1.
3.
And
Divide
it's
both
increasing
sides by
from interval
3.
3, which
4
is
over
3
3
to infinity.
divided by 3 gives us
3
4
to
over
infinity.
9.
And now we also
said
know our answer
that we're
to
going to
C,
add pi at the
because
end.
we know
So
that
we have
it is
4
decreasing
pi over
from
9.
interval 2,
Our final
which
answer
is
for
from
the
1
question,
to 3. So we can
2
just write 1,
cosine
2, 3.
of 3t
And that's all the work we need to show
equals
for
negative
B and
1
C. Now let's go
is
ahead to
that
question
t
D. So in
equals
question D, it's
4
asking what
pi
values are the relative maximum
over
minimum.
9
In this question, we want
and
to find
2 pi
the
over 9.
critical points again. Find
And those are our final
the
answers.
critical
If you
points,
believe
and the
that this
critical
video
points are
helped
gonna be the
you,
same
please
since you have
consider
the
to
same
like and
derivative,
subscribe.
your function isn't
And
changing. Critical
remember to click the bell icon
points.
to keep up with future
And
videos.
then
Thank
2
you.
is to sub values into original function. In our case, it's g of x, and you're going to see what this means in just a moment. So now let's go ahead and do that. Remember, our critical points were x equals 3, x equals 1. We got this by setting our derivative, which was x minus 3 times x minus 1, and we set this equal to 0. And we know that this is 3 because we have to make this parenthesis equal 0, we get 3, and here we get 1. Those are our critical points, 3 and 1. So now we're going to substitute both of these values into our original function. And if you remember, our original function was 2x cubed minus 12x squared plus 18x. So now we're going to substitute in 3 first. So we have 2 times 3 cubed minus 12 times 3 squared plus 18 times 3. So we know that 3 cubed is 27. So we have 2 times 27 minus 3 squared is 9. 9 times 12 is 108. Plus 18 times 3 is 54. We know that 2 times 27, let's just move this to the side, we don't have enough space. Okay, so we had our 2 here. So we had 2 times 27 is 54, so 54 minus 108 plus 54. And then we can do 54 minus 108, which is just negative 54 plus 54, which gives us 0. So now we have a coordinate point of 3, 0. And we don't know if that's our max or min just yet. Let's just go ahead and find what the value is when x equals 1. Again, we're going to substitute in 1 to the equation. So we have 2 times 1 cubed minus 12 times 1 squared plus 18 times 1. 1 cubed is just 1, so we have 2 times 1. 1 squared is just 1 minus 12 times 1 plus 18 times 1, which is 18. So we have 2 minus 12 plus 18, which is negative 10 plus 18, which is just 8. So we have a coordinate point 1, 8. A good way to know which one's your max and min, you just look at the y values. The one with the higher y value is your max, and the one with the lower is your min. So let's write it in red right here. So our maximum is 1, 8, and our minimum value for our function is 3, 0. Pretty easy. Let's go ahead to our last problem, which says sketch a graph based on the answers above. So we're going to sketch it below as this arrow is indicating. So based on the answer, so what I like to do, let's just go ahead and do a light blue. Oh, okay, iPad. Let's go ahead and do a light blue. So here, what I like to do is start off by marking my critical points. And we said our critical points were at 3 and 0. So let's write 0, and then we had 1 and 8. So we have 1, 8, and we have 3, 0. Let's just mark those points really quickly. Let's do it in a different color. Let's go with this off-white, 1, 8, 3, 0. And now what we know is we can look at our B and C where we know it's increasing and decreasing. We said it's increasing from infinity or negative infinity to 1. So we're going to get increasing. And we want to draw the arrow because, again, it's infinity. And we know it's decreasing from 1 to 3. So we can show that it's decreasing. And then again, it's increasing from 3 to infinity. And that is a really bad graph, but it looks something like, oh, okay. But in reality, it should look something like this, where this is your max at 1, 8. This is your min at 3, 0. And then you're going negative infinity and positive infinity. Infinity, negative infinity. I really hope this video helped. And if you believe it did, I would greatly appreciate for you to like and comment for any future video recommendations below. Thank you. In this video, we'll be going over limits in both graphs and equations. To start off, let's go through some background knowledge. Well, the first term we're going to go through is DNE, which means does not exist, which we will see how we will use later on in this video. Next, we're going to have a general limit, which is a value which the function approaches from both the left and the right. Next are some different ways we're going to see questions. The first one is going to be limits of f of x when x approaches. This arrow is signaling approaches, and it says 1, and there's a minus sign in the top right corner. This minus sign means when the graph or the function is approaching from the left side. Then you're also going to see limit of f of x when x approaches 1, and you can see a plus in the top right corner, meaning that when the graph approaches from the right side. And one more way you're going to see it in a question is when x approaches 1 with no type of sign, which is what we learned up here is a general limit. It approaches from both the left and the right, and this is a general limit, so it might have one value, it might have no value, and this is when we would actually use a DNE or a specific value. Now, there's also one more type, which it'll say f of a number. Let's just say 3. And when you see something like this, where it says f of a number, we're going to look at the graph or the equation, substitute that x value in. This is the x value, and we're going to see what the y value is for that x value. Now let's go on to some practice problems. So the first one we have is with a graph. So the first question is limit of f of x as x approaches 2. Well, remember, if we don't have a sign, this is called a general limit. Let's just go ahead and notate that. So this is a general limit. So if we have a general limit, we're going to look at how the graph approaches from both the left and the right. So if we look at this graph, and we're seeing that how does the graph approach at 2? So we can see 2 is right here. We can see that the graph approaches 2 marked by the orange. It's going towards the y value of 1. You can see it's coming down. But then you can see it approaches from the right also towards the y value of 1. Well, if they both approach the x value at the same y value, and when we say approach, and what the arrow's signifying is, let's just say we're going down to 2. What y value are we going towards at that x coordinate? We're going towards the y value of 1. This means that the graph is approaching x coordinate of 2 at a y value of 1. So the answer to our first problem is 1. Let's go to our second problem. And remember, the second problem is this right here, where it's f number, and we're looking for what that y value is at that x value. Here we have an x value of 2, so we need to find out what the x value is at 2. Well, let's go back to our graph, and let's just clear this all up. So now we're on number 2, and number 2 is asking, what is the y value when x equals 2? Well, here is 2, and then we need to look at what the y value is. Well, if we have a hole, it means it doesn't equal anything. But if we have a hole, as we do here, at 2, 1, that means that there is no y value at that point. But we do see a solid dot right here, signifying that this is the y value at x equals 2, And we can see that the y value at this point is 2, meaning that the answer to number 2 is 2. The third question is asking what is the limit as x approaches 3, and we can see that there's a plus sign, meaning that we're going to look at the graph coming from the right. So let's go to the graph and see what happens. So at the graph, we're going to look at 3. Let's clear this all up again. So at 3, we can see that we have a graph coming down here, and we also have it going up here. And since we're looking at a plus, we're looking at the right. So right of 3 is this way. That means that we're looking at this graph right here. Well, that graph right there approaches 3, and it goes to a y value of 2. So when it says approaches, as I said before, we're just looking at what y value does it approach as it's getting to that x value. So it's getting towards the 3, and then it gets to a y value of 2. And you can see that we have a hole there, but when we're looking for a limit where it's a plus, a minus, or a general limit, it doesn't matter if it's a hole or if it's an actual point. That's where the limit would be. Unless we're doing f of a number, that's when the holes don't apply and the solid dots do. Well, since we are approaching at a y value of 2 as we approach an x value of 3, the answer to number 3 is 2. So now we know that as x approaches 3 from the right, the limit is at 2. So the answer to number 3 is 2. Now we can see in number 4 that x approaches 3 minus. That means that we're looking at how the graph approaches from the left. So let's go back to our graph and see how the graph approaches from the left side of our x-coordinate of 3. So let's go clear the graph again, and then we can see how it approaches. So we have 3 right here, and we're looking to the left. And remember, we just did this one, which is from the right, which would be marked by a plus. And since we're doing a minus, we're looking at the left. So as it's coming down from the left, and it's going to our x value of 3, we have a y value of -1. And the holes don't mean anything when dealing with these limits unless you're doing f of a number, meaning that the answer to number 4 is -1. So -1 is the answer to number 4. And then number 5, finally, for this one practice problem, is what is the limit at x approaches 3? And we don't see any type of sign, so this is a general limit. So now x approaches 3. Well, so x is approaching 3 at 2 points, and we don't have any type of sign, meaning we don't care about if it's right or left. We actually care about both. So if we're going down to the right to come to 3, and then we're going up to the left to come to 3, and we have 2 different y values, what are we supposed to do? Well, when we talked about D and E applies when you have 2 different values or 2 different y values for the same x value when you're dealing with these limits. So we can see that when we're approaching from the right, we have a y value of 2, whereas when we're approaching from the left, we have a y value of -1. These 2 values are different, meaning that the answer to number 5 is D and E, since the y values are different. And we'll go more into that in the next practice problem. So these were the final answers to this first practice problem with this graph. Now let's go ahead on to the second practice problem with a graph again. So in this graph, we can see our first question is, what is the limit of z of x, this graph is z of x, as x approaches -1, and it has a plus sign, meaning from the right. So if we're looking from the right, let's go to the graph and look at -1. So we can see that the graph is approaching -1 from the right here. So we can see that as it's approaching this -1 from the right side of -1, so it's going from the right of -1 down and has an x value of -1, we can see it has a y value of -3, meaning that the answer to number 1 is -3. You also might notice that this graph has an asymptote of x equals 1 as noted up here, and that's where it gets interesting in this problem. Let's keep going. So now in this question, it's asking for the limit of z of x as x approaches -1 minus. And that minus again is how it's approaching from the left. So let's go back to the graph and see how the graph is approaching -1 from the left side. Well, we can see that to the left of this -1 point, the graph is going up, up, up until it reaches 5, and at that point, it has an x value of -1. It's approaching this -1 and approaches a y value of 5, meaning that the answer to number 2 is 5. Now number 3 is asking for what is the limit of z of x when x approaches -1, there's no sign. This is a general limit, as we discussed before. So now let's go back to the graph, going to -1. Again, as we said before, if it approaches from two different points. So if it's here, it's approaching to -3 at -1, and then it's approaching at 5. And remember, the open circles really don't make a difference. If there is a value of some sort, whether it be a whole or a solid point, at that x value of -1, and we're looking for a general limit or any type of limit, we are going to assume that that is a value in that limit. It's approaching that value. So we can see that it's approaching -3 from the right, but from the left it's approaching a +5. Two different y values does not exist. Does not exist, D and E. Let's go to the next question, which is asking limit of z as x approaches 1 plus sign, meaning from the right. So let's go to 1. So we can see that at 1, we have that vertical asymptote. Well, there's actually a point that's going towards that 1. Although it may never cross it, as you can't cross that vertical asymptote, there's still a point going towards the -1. Well, remember, we want to try to see what y value it's approaching as the line or the graph is approaching that +1 value. And since we have a 1 plus, meaning from the right, to the right of this 1, we have this 3. We have this line approaching it, but remember, it's not going to cross that vertical asymptote, meaning it's going to be approaching -infinity, which is the actual answer for limit of z of x as x approaches 1 plus. Next, we have limit of z of x as x approaches 1. Well, as x is approaching 1 itself, we know that there's an asymptote. And if there is an asymptote, there's no type of general limit which we can think of, because there's nothing on top of 1, there's nothing below 1, there's no 2 points that have a x value of 1, meaning that that really doesn't exist. So D and E again. Next, we have limit of z of x as x approaches -5, and we have a minus, meaning from the left. Well, we have a -5, but there's nothing to the left of that graph. We can see we have a solid point, there's no arrow, meaning that there's really nothing besides, or nothing to the left of that 5 on our x-axis of that -5. So that means, again, it does not exist, there's nothing there. So let's go and say does not exist. Pretty simple so far. And again, if you have any questions, you can ask in the comments. Next, we have some rules with equations. Now we're going to be dealing with limits and equations together. Originally, we were dealing with graphs. Now we're on to equations. So the first rule, or the main rule, is to complete direct substitution. And we'll get into that later. But an example would be if you have a limit where it says x approaches -1, you're going to substitute -1 into your equation as your x value, as I said here, and see if that works. And we're going to go through and see what works and what doesn't. So this first question is going to be an example of when direct substitution actually does work. So now let's just see what happens. So we have x squared plus 3x plus 2. So the first thing we want to do, as we set up here, is substitute our limit in, which is called direct substitution. So first, I personally like to factor it. So I'm going to put a rule here and say factor first. So let's factor this. So x squared plus 3x plus 2 factors into x plus 1 times x plus 2, and our denominator stays the same as x minus 5. And remember, we're just doing direct substitution, so we're going to substitute in our limit, which is x approaches 1, so we're going to substitute 1 as x. Now let's do the direct substitution. So we're going to substitute our x value as 1. So we have 1 plus 1 times 1 plus 2 over x minus 5, or 1 minus 5. And so 1 plus 1 is 2, times 2 plus 1 is 3, over 1 minus 5 is -4. So we have 2 times 3 over -4. 2 times 3 is 6 over -4. And this simplifies down to -3 over 2. And so we can see that there it didn't go to 0. This equation didn't go to any ridiculous number, meaning that this direct substitution actually worked, and the limit as x approaches 1 is -3/2, and that would also work by graphing this equation. Let's go to our next problem where direct substitution actually does not work. So in this one, we're just going to start by doing direct substitution just to show you it doesn't work. So we have 1 squared minus 1 minus 2 over 1 minus 1. So 1 squared is 1, minus 1 minus 2 over 1 minus 1 is 0. 1 minus 1 minus 2 is -2 over 0, which is just 0. So we can see that we have a denominator value of 0. Well, we can't really have that. So now what we're going to try is going and doing the factoring, doing direct substitution again, and then after factoring, if we get a constant value, we have something special. Well, let's try and factor it. So x squared minus x minus 2, which is our numerator, and we're going to factor that. It factors out to x plus 1 and x minus 2 over x minus 1. If this denominator was x plus 1, we could have eliminated the x plus 1 in the numerator and denominator, effectively making that x plus 1 in the numerator a 1. But we'll see that in a future problem, but we don't have that here. So we're going to keep going. So now, after factoring, we're going to try direct substitution. So again, our limit was 1, so we're going to substitute in 1. And again, we're going to substitute 1 as our, so we have 1 plus 1, which is 2, times 1 minus 2, which is -1, over 1 minus 1. Again, we have -2 over 0, which is 0. And you can see that we're getting a constant number. And I know it's the same equation, but you always need to try to factor and see if you can eliminate any terms. Since we didn't eliminate any terms, we tried this substitution again, and we didn't get anything. When you have this constant value of 0, and you can put in anything, and since we're trying to do that approaches 1, we keep getting 0. This just means we have something called a divergent function or divergent graph. And when it's a constant number, it's a divergent graph, meaning that the limit of this graph is actually infinity. So let me write that. Limit of this equation, the x squared minus x minus 2 over x minus 1, is actually infinity and -infinity. So that's one thing you should write in your notes. When you keep getting a constant number, it's called a divergent graph or divergent equation, and your limit is infinity and -infinity. So now let's go on to our last practice problem, which is the limit of x approaches 9, of x approaches -9, of x plus 9 over x squared plus 11x plus 18. In this equation, let's go ahead and try to factor it. In this equation, let's start out again with direct substitution. So we have -9 as x plus 9 in our numerator over -9 squared plus 11 times -9 plus 18. So in our numerator, we have -9 plus 9, which we know is 0, over -9 squared, which is 81, plus 11 times -9, which is -99, plus 18. So we have 0 over something. 0 divided by anything is 0. And since we know it's 0, we know that this did not work. Direct substitution did not work again. Well, now what we're going to do is we're going to factor, see if we can see if we can eliminate any terms, and then we'll go ahead and see what to do. So we know that we can't really factor our numerator, so we're going to leave it the same. Now let's factor our denominator. The denominator factors out to x plus 9 times x plus 2. And we can see that our numerator and denominator both have x plus 9. We can effectively eliminate this one in the denominator, and the numerator goes to 1. Well, since the numerator is going to 1, we have 1 over x plus 2, and our x value, again, we're going to do direct substitution. Our x value is -9, so we have 1 over -9 plus 2, so we have 1 over -7, meaning it's just -1 over 7, and that is the limit for this equation right here. I hope this video helped, and again, if you need any more help, if you have any questions, just comment below. And remember to like and subscribe, and hit the bell icon in order to get future updates for future videos. Thank you. In today's video, we'll be going over how to find the equation of a function from a graph. So we know that the base equation for a sinusoidal is y equals a times sine or cosine, parentheses b, parentheses x minus d plus c. Now, we know that the a is our amplitude, or our vertical stretch or compression. We know b is the horizontal stretch or compression. We know that c is the vertical shift, and we know that d is the horizontal shift. So we need to see how to get the equation into this form from this graph. Well, we can see that we have a very ordinary looking graph, and let's try to find our amplitude. So in order to find our amplitude, what I like to do is find our max and our min value and divide by 2. So we have a max value of 2, a min value of -4. Let's do -4 plus 2 equals -2. Divide that by 2, and we get -1. -1 is going to be our center point. So if you have a center point at -1, I dashed it with some lines, as you can see right here. And we want to see how far we got from our center line, which we just determined was -1, to get to 2 and to get to -4. Well, from -1 to 2, it's 3, and from -1 to -4, it's also 3. That means our amplitude, or our vertical stretch, is 3. So we have an a value of 3. Now, let's try to determine our b, or our horizontal shift. Well, we're going to do that by finding our period. Now, in order to find the b value, we want to see our period, because we know that our period is equal to 2 pi over b for sine and cosine functions. And now we can try to find our period. So we know that we have an intersection right here at, let's just call this pi over 4. And we have another intersection right here at 3 pi over 4. The difference in these points are equal to our period. So 3 pi over 4 minus pi over 4 equals 2 pi over 4, which simplifies down to pi over 2, which is equal to our period. Well, we just said that our period is 2 pi over b. And since we know that our period is equal to pi over 2, we can set 2 pi over b equal to pi over 2. So now what we can do is try to isolate for b. So it would give us 2 pi over 2 equals b. And then remember when dividing by fractions, you multiply by the reciprocal. So we have 2 pi times 2 over pi, leaving us with 4 pi over pi. The pi's will eliminate each other, leaving us with 4 equals b, or b equals 4. So we just determine our b value is 4. Now let's try to find our c value. And we said that the c value is our vertical shift, up or down. So we can see that we went to a center point at -1. Usually a graph starts at 0, 0. So from 0 to -1 equals -1. So we shifted down -1, meaning that our c value equals -1. Finally, we need to determine our d value, which is the horizontal shift. And the horizontal shift in this scenario is going to be our d value, obviously. And we went over pi over 4 to get our first intersection, meaning that our d value is pi over 4. These are the values, and now we can just use this base form in order to make our equation. So we said that y equals a sine or cosine of b parentheses x minus d plus c. Well, this graph is a sine function, as it starts at the origin, goes to the maximum, goes back to the origin, goes to the minimum, and so on and so forth. So now what we'll do is we'll write it in sine form. We just found our a, b, c, and d, so we can say y equals our a value, which was 3. So y equals 3, and we just said it was a sine because it goes from the origin to the max, to the origin to the min, and so on and so forth. And then y equals 3 sine, parentheses our b value, which was 4, parentheses x minus our d value, which was pi over 4, and then plus our c value. Here our c value is -1, so -1. This is the equation for the graph we have been given. I hope this video helped, and if you believe it did, please consider to like and subscribe, and definitely keep commenting for future videos. Thank you. In this video, we'll be going over how to find the transformations and how to perform transformations of a cosine graph. So, when looking at a sine equation, you'll see y equals a sine, parentheses b, parentheses x minus d, parentheses plus c.
And for cosine, you'll often see y equals a cosine, parentheses b, parentheses x minus d plus c. And you may be asking yourself, what does the a mean? What does the b mean? What does the d mean? What does the c mean? And so the a, b, and c will be listed right below here.
Your amplitude, also known as your vertical stretch or compression. Your b value is your horizontal stretch or compression. Your c value is the vertical shift up or down. Your d value is the horizontal shift left or right.
These are a few steps in order to find or properly graph a cosine or sine sinusoidal. So first is to get all the values like a, b, c, and d, mark the period, the phase shift, then you plot the max and the min points on the y-axis, you plot the period, then you plot the phase shift. Step 6 depends on the type of equation, and then 7, finally you just connect the dots. I would suggest writing all these steps in your journal or your notes in order to remember them for future reference.
Now we are going to do an example using cosine. This example is going to be y equals 3 cosine of x plus 5 pi over 6. Now let's go back to our steps. First we want to label all our values, which are our a, b, c, and d. So we have a, b, c, and d. So our a value is going to be 3, which is the coefficient of our cosine. B value is going to be the coefficient of x. In this scenario, we can just assume it's 1 because there's nothing in front of the x. So we have 1.
Based on the equation, we have no c value, and the d value is negative 5 pi over 6, since the base is x minus d, and we have a positive, so it becomes a negative.
And we said our next step was to find all the values. Now we need to get the period and phase shift. So let's start out with the period. We said the period is 2 pi over our b value for sine and cosine. Our b value was 1, so it's 2 pi over 1, which is just 2 pi. So our period is 2 pi. Next, we need to find the phase shift. We're just going to call it PS for right now, just to make it simple and easy. And PS, as we said, is equal, making this parenthesis equal 0. So in this scenario, it's x plus 5 pi over 6 equals 0. And subtract 5 pi over 6 from both sides, which leaves us with x equals negative 5 pi over 6, meaning that our phase shift, which is essentially our x, is negative 5 pi over 6. Now that we have this, we can now go ahead and graph. But before we go and graph, let's just write this out. Cosine is max, or cosine goes through the max. It starts at the max, goes to the origin, goes to the min, goes back to the origin, goes to the max, and then back to the origin, and then to the min, and then so on and so forth. If it was negative cosine, it would be from the min. It would start out at the min, go to the origin, go to the max, back to the origin, and so on and so forth. Now we are going to go ahead and graph the cosine function y equals 3 cosine of x plus 5 pi over 6. And so we need to start out with going back to our steps. We want to label all our values, which we just did. We found out our period and phase shift. Now we want to plot our max and our min values.
We have a phase shift of negative 5 pi over 6, meaning that the graph would start at negative 5 pi over 6 as its first x value. So to make it look, the graph would look something like this, where we would have an extension and we would have a first point at negative 5 pi over 6 as our first x value.
But we want to get our max and our min.
When calculating the max and min value, we just do c plus a for max and
now
c minus a for the
max
minimum.
value, which is just going to be 0 plus our a value, which is 3, meaning our max is at 3 on the y-axis, and our min value is going to be 0 minus 3, which is negative 3, which is our minimum value. So let's just plot those 2 points on the graph. So we have a max of 3, min of negative 3. And now we want to first plot our first point, or after our period. And again, we're going to do the same thing, similar to what we did to sine, which was going to be phase shift. Phase, I'm just going to put an S, H. Phase shift plus our period equals one of our points. And so phase shift was negative 5 pi over 6 plus our period, which was 2 pi. So we have negative 5 pi over 6 plus 2 pi, which is actually just negative 5 pi over 6 plus 12 pi over 6, which is just positive 7 pi over 6, which is going to be one of our points. Positive 7 pi over 6. All right. So now we're going to do the same method where we do p over 4 to get our points. So p over 4, 2 pi over 4, which is just pi over 2, or just 1/2, or just 1/2 pi. So now we're going to do our phase shift plus our point. Our phase shift is going to be our first point, essentially. So we have negative 5 pi over 6 plus pi over 2, or 1/2. And in this scenario, that's just going to be 3 pi over 6, which gives us negative 2 pi over 6, which is actually just negative pi over 3, or 1/3, negative 1/3 pi. So our second point would be right here at negative pi over 3. And again, we are not really graphing those points since they're not on our graph. We're going to add another 1/2, so which is going to be another 3 pi over 6, leaving us with pi over 6, which is going to be the first point we have on our actual graph, our x value. So then we're going to add another 1/2, which gives us 2 pi over 3. It's going to be another point of ours, 2 pi over 3. And if we add another 1/2, so another 1/2, we get that 7 pi over 6, which is what we have right now after we added our radian to our phase shift. So now we have a total of, let's just count them, 1, 2, 3, 4 points before our period. And now we can actually graph. So basically, we are not really minding it for the points before the graph, but for this scenario, we are going to try to graph them. So again, we said that cosine starts at the maximum, goes to the origin, it goes to the minimum, and then back to the origin. So our maximum here is 3, then we go to the origin, which is right here at 0. We go to our minimum at pi over 6, which is negative 3. Then we go back to the origin, which is at 2 pi over 3. Then we go to the maximum, which is at 7 pi over 6, comma 3. You can connect the dots. So you go max, origin, min, origin, max. We should go back to the origin. So we add another 1/2 to 7 pi over 6, so 7 pi over 6 plus 3 pi over 6 gives us 5 pi over 3, because 10 pi over 6 simplifies down to 5 pi over 3. So we have 5 pi over 3, and so we can graph that. And then we're going back to our origin, so we're just going to connect sort of like that. And again, I'm so sorry for this terrible graphing. You're just going to be graphing like that and going there. Then we're going to go to our minimum. Our minimum, again, 13 pi over. So we're going to add another half, which is another 3 pi over 6, to the 10 pi over 6, which gives us 13 pi over 6. Our next point is here. We go to our minimum, and we connect the dots. And then you just continue this pattern. So 13 pi over 6, and then you get 16 pi over 6, which is just 8 pi over 4, which is just 8 pi over 3. So you'd go back to the origin. And then you would add another 1/2, which would give you 19 pi over 6, and you would go back to your maximum, back up, and then back to the minimum at 22 pi over 6, which simplifies down to 11 pi over 3. So it'd be like that, like this. And then you go back to the min, and so on and so forth. Well, this is the way you have to graph cosine and sine. It's a long process, but it's what we need to do. I hope this video helped, and if you believe it did, please consider to like and subscribe, and feel free to rewind any part of this video. In today's video, we'll be going over how to get the cosine from the unit circle. We have the equation 2 cosine of 3t equals -1. To start off, we're going to divide 2 by both sides in order to get left with cosine of 3t equals negative 1 over 2. We have cos of 3t equals negative 1/2. How I like to think of it is disregard the 3t and just think about when does cos of theta equal negative 1/2. And in order to find this out, we're going to refer back to our unit circle, as we can see right here. Here we have cosine and sine. Cosine is denoted by our x value. So cosine equals x and sine equals our y value. Now, just by looking at the unit circle, we need to identify which radians have a cosine or an x value of negative 1 over 2. So now, looking at the unit circle, we can see that 2 pi over 3 has an x value of negative 1/2. We can also see that 4 pi over 3 has an x value of negative 1/2. So now, I'm going to write both radians off to the side. So we determine 2 pi over 3 and 4 pi over 3 both have a cosine of negative 1/2. Next, what we're going to do is we're going to look at these two radians right here, and we're going to bring it over here. Now, what I do is we can think about it like this. We can think about it as 3 of t equals 2 pi over 3, and we can also think of it as 3t equals 4 pi over 3. You might be asking yourself why we did this. Well, we know that 3t, or the cosine of 3t, is going to equal negative 1/2, and we know that 3t is going to be equivalent to 2 pi over 3 or 4 pi over 3. What I like to do just to make things simpler is disregard the pi and add it back at the end. So we can just think about this as simple algebra. We have 3t equals 2 over 3. We just disregarded the pi. We're going to add it back at the end. And we have 3t equals 4 over 3. Now, in order to get rid of the 3, we're going to divide by 3 on both sides. If we divide 2 over 3 divided by 3, we get a total of 2 over 9. So this equals 2 over 9. And again, we said we're going to re-add pi at the end. So we know that one of our answers is t equals 2 pi over 9. Then we're going to do the same thing for the 3t equals 4 over 3. Divide both sides by 3. 4 over 3 divided by 3 gives us 4 over 9. We said that we're going to add pi at the end, so we have 4 pi over 9. Our final answer for the question, 2 cosine of 3t equals negative 1, is that t equals 4 pi over 9 and 2 pi over 9. And those are our final answers. If you believe that this video helped you, please consider to like and subscribe, and remember to click the bell icon to keep up with future videos. Thank you.